All right, I want to go through the answers here to these questions that are on the quiz. It'll look a lot like this tomorrow, so you should be very well prepared after we go through it. What is a mole? A mole is a counting unit for small, and I emphasize very small, items. Okay, how big is it? Obviously, we've seen this before, but 6.02 times 10 to the 23rd atoms would make it up for an atom. What is an isotope? An isotope is an atom of the same types, but with a varying mass, and that mass is due to a change in the number of neutrons. So, for example, carbon-12 and carbon-14 are two isotopes. Carbon-12 has 6 protons and 6 neutrons. Carbon-14 has 6 protons and 8 neutrons. So then that leads us to the third question here. As it says, why is the atomic mass on the periodic table called average? Well, it is an average because these are not equal. And so, for example, the average on the periodic table is 12.011 for carbon, which means that it's probably 98% carbon-12 and about 2% carbon-14. And so it's an average. Remember that no atom weighs 12.011. All right, let's do some calculations then. 10 moles of lead to atoms of lead. Well, 10 moles times 6.022 times 10 to the 23rd atoms per 1 mole. Moles cancel, and I end up with 6.022 times 10 to the 24th atoms. All right, the next one here, I've got 50 grams of water to moles of water. Well, 50 grams of H2O times, I know that 1 mole of H2O is 18 grams. So then that works out to be roughly 2.78 moles of water. One more on this page here. I've got 5.5 times 10 to the 34th atoms, and I want to convert that to grams. So this is of calcium. Well, I know that 6.022 times 10 to the 23rd atoms is 1 mole. And I know that when I look up calcium, 1 mole is roughly 40.1 grams. Actually, let me go back here. It is rounded to just 40 grams. We'll just keep that at 40 grams. So when I go through and do my punching in on my calculator, 5.5 second function e to the 34th times 40 divided by 6.022 second function e to the 23rd, I end up with 3.65 e to the 12th grams. All right, so there are 2 more problems left here that we want to get through. 400 grams of neon to atoms of neon. So 400 grams of neon. Well, I know that neon is 20 grams to 1 mole. And so then I have 1 mole is 6.022 e to the 23 number of atoms. So grams will cancel and moles will cancel. And now I have this large number, so I punch it in, 400 times 6.022 to the 23 divided by 20. I come up with 1.204 e to the 25th atoms. 15 moles of argon to grams of argon. Well, 15 moles times, I know that 1 mole of argon, I gotta take a break here and look that up. So I come up with 39.96, or we can just round that to 40 grams per mole. So I take 40 times 15 moles, and we come up with roughly 600 grams of argon in 15 moles. All right, down here we've got some problems that we kind of did before, but a good review here since we really haven't had a quiz on them. The good thing about these is it gives you some information, but not all information. So these are really good because they give you just little bits of information, but you should be able to figure it all out. So right here with calcium 41, we can see that the mass is 41. We look up and know that calcium is element number 20, which means that it has 20 protons, and since these are atoms, we're going to assume that it has 20 electrons. The difference here would be 21 neutrons. Atomic number 12 here, that means that this is carbon. If it's got 6 neutrons, okay, carbon has 6 protons, 6 electrons, it has a mass of, oops, I'm going to go back and erase all that silliness because I jumped too far ahead here real quickly. Okay, so the atomic number is 12. That is not carbon. Sorry, that is magnesium is what that is. And because it's magnesium 12 with 6 neutrons, that means the weight is 18. So its atomic mass is 18. It has 12 protons and probably 12 electrons and only 6 neutrons. Kind of screw up there, sorry. Now we go lead. Well, I know that lead has an atomic number of 82, which means 82 protons and 82 electrons. In this case, it has 206 for the mass. Well, when I take that 206, so that gives me 124 neutrons. Now we have carbon 14, means the mass is 14, means that the atomic number is 6. That would be 6 protons and 8 neutrons to form that. And then the number of electrons is 6. So just a quick little review. I'll go through the back side of the page here next. All right, so let's jump onto the back side here, and let's start out with this equation, top and balance. At 2 Ks, I need a 2 there. 2 CLs, I'll need a 2 there. 2 LIs, 2 LIs, so 1, 2, 2, 1. Okay, so there's our balance. You have 10 grams of K2O and 10 grams of LiCl. What's the limiting reactant? Well, 10 grams of K2O, and K2O is going to have 39.1 plus 16, so it's going to be 94.2. So I had 39.1, 39.1, and 16 to give 94.2. LiCl is going to be 10 grams out of, I got 6.9 and 35.5, giving me 42.4. Okay, and I got that from 6.9 and 35.5 for chlorine. Okay, so when I divide, 10 divided by 94.2 is 0.106 moles. And when I take 10 out of 42.4, I get 0.236 moles. Now, the ratio here from this problem is supposed to be 1 to 2. Okay, but I have 0.106 and 0.236. This is excess because there is more than twice as much. This is the limiting reactant. So K2O is the limiting reactant. So what is the amount of KCl that you'll make? Well, for every 1 K2O in the equation, it says I'm going to make 2 KCl. So if I was going to make 0.106 moles of K2O, that would mean I would make 0.212 moles of KCl. How many grams of KCl would I make then? Well, I would take the 0.212 moles of KCl times the mass in grams, which is going to be 39.1 plus 35.5. So 39.1 plus 35.5, I get 74.6 grams per 1 mole. So times 0.212, I come up with about 15.8 grams of KCl. Now we get down here to the formula. It says what would your error be? Well, remember we go experimental minus accepted divided by accepted, absolute value times 100. Well, the experiment, you actually got 5 grams in the experiment, okay? So the experimental, that's right there. That would be 5 minus 15.8 divided by 15.8 times 100. So when I do all my math there, 5 minus 15.8 divided by 15.8 times 100, quite a bit off. We were 68.4% error. Remember, there is no plus or minus to that. Okay. When you finish this page, and you'll probably have a few minutes left in class here, 2 things for you to work on today is I want you to finish up and make sure that you have your Flipgrid done by the end of the week with your term. If you did not get a vocabulary term, email me and I will send you one. And then also your Google presentation is due by the end of the week. So get together with your partners, make sure that your presentation is solid, it's good, and it shows exactly what you did for your lab. Email me with any questions.